All right, so yeah, like Camilla pointed out on this coordinate system, okay, you put the quantities of the two products that you're producing. So it doesn't matter where you put large or small as long as you're consistent with both graphs. Usually I put, small down here, right today, okay, and large up here, okay, then 0 is your origin. Similarly for Brazil, you have large here, origin, and small. Okay. The next is when you mark the axes with the actual quantities you know. So for the US, we know that we can produce up to 30 large airplanes, right? Because if we did all we could, we can make 30 large airplanes. And small airplanes, we can make, okay, up to 40. I guess I better erase this. Okay, so, okay, and for Brazil, the most they can do is 10 large, and then the most they can do with small is 30 small, okay? Now, we kind of already said the endpoints, right? The endpoints of your PPF is right here with 30 large and 0 small, because every point on this graph tells you 2 pieces of information. And on this end is 40 small and 0 large. Right? Similarly for Brazil, it's 10 large and 0 small, or 30 small and 0 large. Everybody with me so far, right? What do you do next after you've established the axes and identified the quantities and endpoints of your PPF? What do you do?
Draw a line connecting the 2 dots.
Okay, you draw a line to connect these 2 dots. Now my question is, okay, do you draw a straight line? Well, that was totally off, so hold on. Okay, like that. Or do you draw a curved line like this? Which one do you do?
On this one, I think it's a straight line, but I think in reality, like most of the time, it's a curved line.
Okay, good. Josh?
In the exercise, it said it was constant, the opportunity cost, so it's a straight line.
Okay, very good. So the clue, both Nate and Josh are correct, because the clue in the setup of this question says both countries have constant opportunity cost, right? So that, I'm glad some of you picked it up, because that's telling you it should be a straight line for this question. Now, if you took Econ 151 or 150 from me, you'll remember I told you that in that level of the class, you only dealt with straight lines because that made your life easier, which is true. Okay, and I said if you went on with economics, one day you'll deal with curved lines. So today this is a review of 150, 151, so we're still doing a straight line, but now after this week you are moving on to deal with curved lines, and we'll get there in, I think, I can't remember if it was chapter 2 or chapter 3 that you'll see it, okay? But the point is right now, okay, it is a straight line because of the condition of constant opportunity cost. Okay, and similarly, because both countries have constant opportunity costs, you have a straight line for Brazil as well. Okay, now so how does opportunity cost get reflected in a graph like this? Because I said that one phrase of constant opportunity cost made sure you're drawing a straight line. So where is opportunity cost in this graph? How do you find it, or how is it related to PPF?
Runs along the line.
Sorry? Okay, I have several of you that don't have your videos. Can I ask you to activate your video so I can call on you?
Would it be the slope of the line?
The slope of the line, very good. Okay, so yeah, the slope of your PPF actually denotes the opportunity cost, and specifically the opportunity cost of your product on your horizontal axis. Okay, so I'll write that down. So the slope of your PPF, okay, and you want to make sure you write this down as well, right, is always the opportunity cost of your horizontal product. What I mean by that is, well, in this particular case, small airplanes are on your horizontal axis there. So the slope of this PPF for the US is the opportunity cost of producing one small airplane, right? So if you do the slope, it's rise over run, so that's 30, is rise over run of 40, and that gives you 3/4. That means for every small airplane you produce, you lose 3/4 of a large airplane, because opportunity cost measures what you give up when you choose to do something, right? So when you choose to make one small airplane, you're giving up 3/4 of large airplanes that you could have made with the same resources. Okay, does that make sense? So that's what the slope of your PPF tells you. Okay. All right, everybody with me? Okay.
And you can also do the inverse of that. So say I had the large planes on the horizontal axis, then it would just be 40 divided by 30.
Correct.
40 over
right.
30.
So if you had drawn your graphs, putting the large on the horizontal axis, then the slope of that line would have been the large airplanes opportunity cost. Okay. Or if you drew it this way, like you said, just take the inverse of that, just do run over rise, and it would be the opportunity cost of your vertical axis product. Okay. Very good. Okay. Now I do want to talk about the curved line.
Yeah, a very
you have
quick
a question,
question.
Uh-huh.
Yeah, so what's the difference between the opportunity cost and marginal cost? Because I was thinking like the slope of the line to be the marginal cost.
Okay, very good question. Okay, so in this particular case, when it's a straight line, because your opportunity cost is always the same, it is also your marginal cost. Okay, however, when you have a curved line, then that changes, right? So when it's not a straight line, those two can be totally different. Okay, but yeah, very good question. Okay, and okay, so now let's look at the opportunity cost of, or not opportunity, what happens with a curved line, okay? So let's say that we're still looking at the US and everything else is the same except that we don't have the condition of constant opportunity cost. Okay, so you end up having oops, that was terrible. Okay, you end up having it's thinking I'm trying to connect two dots. I'm trying to draw here. Okay, you end up having a curved line like this. Okay, now this is different than the straight line, because what happens to the slope of a curve? Is it constant and always the same no matter where you are on the curve? No, it's constantly changing. Right, so that means as you produce more and more of a product, your opportunity cost of producing is going to be different, okay, as you go. So let me demonstrate how that works. So let's say that you and I are now sitting on the board for Boeing. Okay, you've made it in your early 20s. You were a Boeing board member, and in the beginning of the year, we're trying to meet together to figure out our production plan. Let's say that we've produced our small airplanes we call 737s for decades, and they've been around since the early 1980s. So very successful, but we're kind of bored of the small ones. And we just came up with a new awesome, double decker we call 797, right? And it's a large airplane and super high tech, fuel efficient, beautiful, and this time we did it right, so it's not gonna fall out of the sky like we did with 737 Maxes. That was just a patch job. And I don't know if you guys remember a couple years ago, 737 Maxes fell out of the sky like twice within 3 months and killed hundreds of people, so it was terrible. But anyway, so we corrected all the mistakes. We have a new 797 we're extremely proud of. So at the beginning of the year, okay, we're meeting and we're confident that the world is going to just love our 797s and nobody wants to go back to the old 737 model that has existed for 40 years. So we decided we're going to produce only large airplanes. So we're going to produce at point A, right here. Okay, and now let's say that after 1 quarter, we meet back trying to look at how things are going for us and decide if we need to adjust our production plans or not. And to our surprise, our customers are still calling about 737s. So they keep calling and say, hey, what about those small airplanes? Are you guys going to make some? We want to order some. And so we decided, you know what? Okay, the world is dumb, right? It'll take a while for them to catch up to our geniuses. And in the meantime, we decided to make some money. So we said, okay, let's just make 10 small airplanes while we wait for the demand for large airplanes to catch on, right? So that means if we decide to make 10 small airplanes, we are going to move our production from point A, let's say, to point B, right? At point B, if I come over, you can see that looks like 29 large airplanes. Okay, oh, I know the 29, 30 are kind of squished together. Let me try to fix that. Okay, so I'll put 30 a little bit higher than 29 right here. Okay. So what is the opportunity cost of making these 10 small airplanes?
One large airplane.
Just one large airplane, right? We gave up one large airplane and gained 10 small airplanes, okay? Now, let's say that after the 2nd quarter, we meet together and we're frustrated because we're like, man, the world is dumber than we thought, okay? They're still calling about small airplanes. And it's taking, sure, a long time for the world to catch on our genius new products, right? So we decided, you know what? Okay, well, give the world a little bit more time, and we're gonna make 10 more small airplanes just to make money for now, okay? So we go to point C, where we add another 10 small airplane production, and at point C, if we come over, it looks like, I don't know, just guessing, you know, looks like about 23 large airplanes here, right? So what is the opportunity cost of the 2nd batch of 10 small ones for us?
6 large airplanes.
Okay, 6, not 7 large airplanes, right? Because when we added 10 more, when we went from 10 to 20, we moved from point B to point C. So that means we lost 6 large airplanes because we went from 29 large to 23 large, right? So the 2nd batch of 10, we gave up 6 large airplanes. Everybody with me, right? So now let's say the same thing keeps happening. By the 3rd quarter, we decide to move to 30 small airplanes, adding another 10. And you can see by then, okay, if we come over here, this looks roughly like 14, okay? So the 3rd batch of 10 cost us 9 large airplanes, and then by the end of the year, we totally give up on innovation and say the world just doesn't know how to appreciate geniuses, and we give up, right? Just give them the same old thing and let them work on, use those. And the last 10 small airplanes, when we go from D to E, cost us 14 large airplanes. Okay, so what's going on here? We added exactly the same amount of small airplanes every time, just 10, 10, 10, 10, right? But the opportunity cost went from 29 to 3 to 9 to 14. Every time it went higher and higher, okay? So this is called the law of increasing opportunity costs of production. So the law of increasing opportunity costs. Okay, so the law of increasing opportunity cost says as you produce more of something, your opportunity cost of production is going to get higher and higher. Okay, and so why is that? Right. Well, let's contrast this with the straight line we saw. With the straight lines here for these countries, what we're assuming is that no matter how much you produce, okay, the resources can be switched between the 2 products at a fixed ratio. So we figured out that for every small airplane we produce, the opportunity cost is 3/4 of a large airplane. What we're saying here is really, if you take a small airplane wheel, you can rip it open and that will be 3/4 of a large airplane wheel. Or if you clip a small airplane wing and spread out the material, that's going to be exactly 3/4 of a large airplane wing. And then all other resources will work this way, no matter how much you produce, okay? Now, that sure would be convenient, but in real life, it doesn't really happen, right? Because of what's something called specialized resources. Okay, specialized resources mean that, well, resources do not get switched between products at a fixed ratio and just work no matter how much resource you throw at a certain product. Okay, and because of that, you have the law of increasing opportunity costs. So this curve is is more realistic than the straight line. Now, let me use one example to help you understand what I mean here by specialized resources causing you to have the law of increasing opportunity cost, okay, or a curved PPF. So I'm going to use labor as the example, okay, for two reasons. One, labor till this day with our technology advances and et cetera still accounts for 70% of production costs. People are expensive, right? You have to pay them money, they get sick, you have to give them insurance, or they need vacation days, so you pay them to not work so they don't break down and go mental, right? So people are expensive. Labor costs a lot of money. But also, okay, I choose labor so that you can relate to it more easily because you are a human being that is going to join the labor force. Even if you own your own company, you're an entrepreneur, you still have to put your human effort into your work, right? So for a company like Boeing, an airplane producer, if they have different products like large versus small airplanes, they're going to have workers that specialize in each product, right? They're going to have engineers that went to school, got trained in designing and building large airplanes versus some others that went to school that got trained and specialized in small ones, because these airplanes don't work exactly the same depending on the size, right? So what's going on is when we were at point A right here in the beginning of the year, okay, who's working on the large airplanes?
Likely everyone.
Everyone, right? Because A is a point on our PPF, which means it's an efficient point, and any point on the PPF, we call it efficient, right? And efficient means you are using all of your resources. Nobody's sitting idle, okay? So at point A, since it's on our PPF and it's at the end, that means all the resources are being used for large airplane production. So including all the small airplane engineers. And now they're going to feel pretty lost because they'll go there and say, okay, I have no idea what the heck I'm doing here. I've never dealt with a airplane tire this big before. How do I install this, right? Or I like to have buttons on my dashboard, and what's with all this touch screen stuff? I don't know how to do this. And so they're all working on large airplanes, doing their best, but they're probably not very good at it or very happy with it. So when we announce, hey, we need 10 small airplanes built, okay, they're going to be the ones that say, hey, please send me. I know what I'm doing there, and I hate my life here, right? So in the beginning, we're always going to put specialized resources in small airplanes towards small airplane production right away. We're going to send those small airplane engineers to make those first 10 small airplanes, right? And they're very good at making the small airplanes, so they can build the 10 pretty quickly. They are very effective and efficient. And since they really stank at making large airplanes, pulling them away really didn't hurt large airplane production much, right? We only lost one large airplane because of it. However, as we go from A to B, B to C, and C to D, and D to E in this process, by the time we get to E, everybody's working on small airplanes, including all the large airplane engineers. So in this process, we're shifting more and more non-specialized resources toward small airplanes, right? And in fact, at the end, when we go from D to E, we're telling all the large airplane engineers, hey, you guys need to go work on small airplanes. And they're going to become the ones that are frustrated and not knowing what they're doing and being very inefficient, right? So we would have to put a lot of them over to the small airplane side in order to make 10 small airplanes, because they're not very good at it, okay? And then by pulling a lot of them away from large airplane production, then we lose a lot of large airplanes as a result in opportunity cost. Does that make sense? Okay, so because resources cannot all freely be switched between different products, then you have this bowled out shape of a, or concave shape of a curve, curved PPF, which tells you about the law of increasing opportunity costs. And again, this is something you will be dealing with more now in this class as we move forward. At least for the next couple chapters, we'll have specific examples of how this affects trade decisions. But I just wanted to introduce this idea, review it with you really quickly, okay? All right. Okay, now, just one more thing about part A, just those dots. So if we have a point right here, is that attainable? It is, right? We can definitely afford to build 10 large and 10 small airplanes in the US, but what about its efficiency at this point? Is it efficient? No, it's not efficient, okay? So being being inefficient at this point means we have resources sitting idle. We have people that are unemployed, or or machines that are not being used, or factories sitting idle, whatever it is, we have resources not used, okay? Now, what about a point right here on the PPF? Is it attainable? Yes, okay? What about its efficiency? Is it efficient? Also, yes.
Yes.
So, yeah, any point on the PPF, including the endpoints, are both attainable and efficient, okay? So that means you are using all your resources to produce something, okay? And then what about a point right here? Is that one obtainable?
Unattainable.
No, it's unattainable because this is a point above our PPF. That means given our resources and technology, no matter how hard we try, we simply will not produce up here. We can't. We can't get here. The only way to get here is if we have a new technology or new resources that can help us produce more. Okay, so that's unattainable. Okay, and since it's unattainable, there's no efficiency to talk about. You know, there's no efficient or inefficient. It's just impossible. Okay, all right. Okay, any questions about part A before we move on? Okay, if not, then let's look at. Oh, go ahead. Yeah.
I did have a question about the curved PPF.
Okay.
So the opportunity cost is the slope.
Mm-hmm.
When we're finding the opportunity cost, are we going to do it like in this situation where we look at how many units we lost when we transferred, or are we going to be using calculus and using?
Well, so you should be using calculus, but this class doesn't require calculus as a prerequisite, so you will not be using calculus. And the most common way to do this is I would ask you something like, you know, what would be the opportunity cost of the 25th small airplane? And then what you do is you say, okay, if the 25th is between 20 and 30 right here. So when we did a 10 here, we lost 9 here. So on average for each of those 10 planes is 0.9 large airplanes. And then you say the 25th is 0.9. You just take an average by section, okay? So yeah, you know, the ideal way is to use calculus and take the derivative at the 25th product there, but
will the answer vary that much typically?
Not enough for you to somehow not understand what we were trying to teach in principle.
Okay, sounds good. Thank you.
You're welcome. Okay, all right, let's look at B really quick. Okay, so question B there asks you to figure out, okay, who has the comparative advantage? Well, so who figure out the opportunity costs of making large airplanes, and then determine who has the comparative advantage in making large airplanes. And then what about small airplanes? Again, I'll give you just a minute or two. Shouldn't take you too long to figure this out, and then I'll stop you and we'll look at it together. Okay, so go ahead and try to figure that out. And don't just wait for me to tell you the answer. I want you to actually try to calculate it, okay? I'm gonna change my curtain again and see if that can help me not glow so much. All right, you guys figured that out yet? You think? Okay, good. So let's talk about that really quick. Okay. Now, if you recall from Econ 150 or 151, when you first learned this, the textbooks usually teach you to figure out opportunity cost by giving you a table, and then you list different quantities, and then you find the ratio and etc. And that has always been very confusing to me. Okay, so I'm going to teach you how I do it, and hopefully that makes sense. If not, then you can always go back to the tables. Oh, wait, what happened? I think my Zoom just dropped for some reason. Give me a second. Oh. Okay, I'm back. All right. Yeah, so that was my iPad Zoom that just randomly dropped. Okay. All right, so the way I look at it, especially in this case where you know the maximum quantities, okay, is that, well, for the US, we know in 1 year, if we devoted all our resources to large airplanes, we can make 30 large ones. And similarly, if we devoted all our resources into small airplanes, we can make 40 small ones. So to me, these two must equal in value because both represent the best we can do with all our resources in a year, right? Okay, so for Brazil, similarly, they can produce 10 large or 30 small. So those two must equal in value to them because, again, those both represent the best they can do in a year. Okay, everybody agree with this? Right? Nobody's freaking out and saying this is bad math. I know if you're a math major, this looks scary, but you know, this gets the job done, right? So when I ask you, well, okay, calculate the opportunity cost of producing large airplanes in both Brazil and the US, what I'm really asking you is, what does 1L equal to in terms of small, okay, in both countries? Well, how do you turn 30L to 1L?
Divide by 30.
Yeah, divide the 30L by 30, right? Then to make sure the equation still stands, you divide the other side by 30 as well. And then you get 1L on this side and 4/3 of a small airplane, or 1.33, if you will, small airplanes on the other. Okay, similarly, for Brazil, you divide both sides by 10, you get 1L equals 3S. So this tells you in the US, when we make one large airplane, we give up 4/3 of small airplanes, and when in Brazil, when they make one large airplane, they give up 3 small airplanes. So how do we determine compared advantage then, once you know this information?
Who has the lowest?
Okay,
Yeah, the lower
Matthias?
opportunity.
Yeah, or yeah, go ahead.
All right, no, just who has the lowest compared? Like Brazil's giving up more of small airplanes, so they have a more competitive advantage on small airplanes.
Okay, so let's look at it from the large airplane perspective. I think is easier to understand, right? So you look at the opportunity costs of large airplanes in US and Brazil, and whoever has the lower opportunity cost then has the comparative advantage, right? Because here in the US, when we make one large airplane, we give up less small airplanes than Brazil does, right? Because when we make one large, we give up 1.33 small. When they make one large, they give up 3 small. So we have the comparative advantage. Comparatively, we have the lower cost. Okay, does that make sense? Now, my next question is, well, once you determine that the US has comparative advantage in large airplanes, can you, without calculating anything, safely conclude Brazil then must have comparative advantage in small airplane production?
That would make sense to me.
Okay, that would make sense. Yeah, I see a couple more nods. Most people are like, I better not say
I don't
anything
think
to
you
get
can.
on the wrong side. Oh, Grace, what'd you say?
I think you cannot.
Okay, Grace said you cannot. Okay, now some of you say you can. I saw the nods, and most of you, like I said, were holding your head perfectly still to make sure you don't get on the wrong side of history here. Okay, all right. So let's talk about this. Okay, the answer is actually yes, you can. Okay, because well, turns out opportunity costs are just mathematical inverses of each other. They're relative, right? So the way, of course, to verify is to calculate the opportunity cost of the small airplanes. So what we want to figure out is how much 1s equals to in both countries. And let's look at how that works and then see if that helps you understand, okay? So if I want to get, okay, I always wipes out more than I'd like. Okay, if I want to figure out what 1s equals to in both countries, you can see in the US, I need to divide 40s by 40 and then divide the other side by 40 to keep the equation standing. And that gives me 3/4 of a large. Okay, in Brazil, I have to divide both sides by 30, and then that gives me 1/3 of a large. So first of all, Brazil does have the lower opportunity cost here. When they make one small airplane, they give up 1/3 of a large. When we make one small airplane, we give up 3/4 of a large. So first of all, Brazil does have the comparative advantage in small airplanes. Now, if you notice that here, okay, when we did one large, it equals 4/3 small. When we did one small, it equals 3/4 large. So really, it's just the same numbers flipped in the ratio, right? Similarly, for Brazil, one large is 3 small. 3 small is really 3/1 small. And then if you flip it, one small is 1/3 large. So your opportunity cost is relative. It's always, you know, the mathematical inverses of each other, you know, between the two different products. And because of that, when you have the lower cost in one thing, once you flip that cost, your cost for the other product must be the higher cost now. Does that make sense? So because of it, once you know that the US has a comparative advantage in large airplanes, you know for sure Brazil has the comparative advantage in small airplanes. You don't have to verify mathematically to draw that conclusion. In fact, this is one thing you want to remember, especially since we're going to talk about trade for the rest of the semester. No country can have comparative advantage in everything, okay? No producer, I should say, not just country, no producer can have comparative advantage in everything, okay? In theory, there's one case where you can have producers or countries that have identical opportunity costs. In that case, then there's no comparative advantage for anybody. You're just exactly the same. But as long as you have any difference in opportunity costs, then you will share comparative advantages. You will have some, and then the other producer will have some others. Okay, does that make sense? All right. Now, related to comparative advantage, we also have absolute advantage. Okay, so how do we determine absolute advantage? What do you look at there? Do you also look at opportunity cost?
You just look at who can make the most of something. Like the 40 small is bigger than the 30 small of Brazil, so the US has the advantage there.
Okay, very good. So the thing is, there's a condition there, right? So Nate is right, but the condition is given the same resources, okay, who can make more of something? Or another way of looking at the same coin on the other side is who can make the same amount of products using fewer resources, right? Because if you can make more given the same resources, that means you can make the same quantity using less resources. That's the same idea. Right? So here in this particular question, the only resource I mentioned is time, right? How much you can make in 1 year. And clearly the US then has the absolute advantage in large because we can make 30 and they can only make 10. And we have the absolute advantage in small because we can make 40 and they can make 30. So one country can have absolute advantage in everything, okay? And now trade, this is again something that you'll remember going on forward in this class. Trade, is it based on absolute advantage or comparative advantage? Yeah, trade is based on comparative advantage. So one common false statement you hear a lot, especially in the news, is people who failed their Econ 151 in college pretend to know what they talk about. They come on the news and say, hey, look at this, right? The US is clearly superior in production in everything compared to Brazil. We can make more large airplanes and we can make more small airplanes. So why the heck are we trading with Brazil? Because when we trade, we're really just killing American jobs and giving those Brazilian workers more pay and more opportunities at the cost of the US. Right? So if we are patriotic, we should totally kill trade with Brazil right now and bring all the production back to America because we clearly are better at everything anyway. Okay, well, that sounds very passionate and intriguing and patriotic, but it's completely BS, right? So don't ever fall for that because it is not true, because trade is not about your absolute advantage, but rather your comparative advantage. Okay, and in fact, I intentionally designed this question that the US has absolute advantage in everything and still hopefully show you and that trade can benefit us, not just Brazil, but us as well. Okay, so anyway, let's move on unless there's more questions about about part B. Any questions about part B? Okay, if not, then let's look at C. C says, okay, if Brazil and US decide to trade, how can the terms of trade, which is the relative price between large and small airplanes, be determined? And what is the acceptable range for the terms of trade? So here, terms of trade, again, is just the quote unquote price of your trade. We don't call it price, we call it relative price because here we're assuming you're trading large and small airplanes without money involved, okay? And so we call that terms of trade. But turns out there is an acceptable range that both countries will be okay with. And if you push outside of that, then one country will not be happy about it, okay? So how do we determine that? Well, the way to do that, because of time, I won't give you time to work on your own and then bring you back because I still want to do some review on micro stuff as well. But because of, the way to think of it is to think of every country's bottom lines, right? So let me just bring this information back, right? So according to trade theory, if we have the comparative advantage in large airplanes, what should we do with our production?
Only specialize in large airplanes.
We specialize in large airplanes, very good. Okay, so we will be making, for now, only large airplanes, and once we talk about the curved PPF, that's going to change a little, but still we're going to specialize toward large airplanes and make as many as we can. So in this case, that means we will only make large airplanes and no small, okay? So that means we will be selling large airplanes for small ones, and Brazil will be only making small and selling small ones in exchange for large, right? So if that's the case, if we are selling large airplanes, what is our bottom line? What is the lowest price we will accept from Brazil when we sell for each large airplane? How many small ones do we have to get at a minimum?
At a minimum would be 4/3 of a small.
4/3, very good. Our own opportunity cost, right? Because we will be going to Brazil and say, hey, you got to pay me at least 4/3 of small per large, because if you give me any less than that, it's not worth my cost of making my large airplanes. Okay, so what we're saying is, for us, the condition is one large airplane has got to be worth greater than or equal to 3/4 not sorry, 3/4, 4/3 of small airplanes, right? That's our bottom line, okay? Now, for Brazil, when they're paying for large airplanes, what is the highest price they're willing to pay for each large in terms of small airplanes? What is the most small airplanes they're willing to give us for one large?
3.
Yeah, right? So they'll say, fine, but one large has got to be less than 3 small, because if we pay more than 3, it's not worth it for us. It's higher than our own cost, and it'd be worth it for us to make our own large. Well, if you put these two together, really, you identify the range that one large airplane's value needs to be in between 3/4, sorry, not 3/4, 4/3 of small airplanes and 3 small airplanes, okay? So anywhere in between this, both countries will be okay with it. Both countries will gain, because we'll be able to sell large airplanes at a higher, quote unquote price than our cost, and Brazil will pay less than their cost. So the way to find it is to always go between your opportunity cost of that same product and then look somewhere in there, okay? All right, does that make sense? Now, you can go outside of this range. You don't have to stay in this range, but then, or I should say, toward which end depends on your negotiation power. The farther away you push your terms of trade away from your own opportunity cost, the more you'll gain. And if somehow the US can convince Brazil that one large airplane should exchange for 7 small ones, then the US will rip Brazil off and gain a whole lot at Brazil's loss in that case, right? So you don't have to stay in this range, but most countries are not stupid, so they know where their bottom lines are, and most of the time we stay in that range, but then they try to push the actual terms of trade far away from their own bottom line, and so they can gain more, okay? All right, questions? Okay, if not, then let's look at D. So D asks you, or gives you some assumptions first, that, suppose before trade, the US produces and consumes 18 large airplanes and 16 small ones, and Brazil produces and consumes 8 large airplanes and 6 small ones. And then the terms of trade to be 1 large and 2 small. Show how trade is beneficial. And I gave you a hint that says, look at the total world production before versus after trade. So let's look at the total world production. Now, I want to point out there's nothing special about 18 large and 16 small and 8 large and 6 small. All I did was I went to your PPF and I just picked a point on each PPF and used that. Okay, so there's nothing special about these numbers. You can pick any point as long as it's a point on your PPF, that will work. Okay, so that's just an arbitrary number from your PPF. Now, the way to look at it, okay, we said, okay, so before trade, we know the US produces 18 large and 16 small, and Brazil produces 8 large and 6 small. So the world total, okay, since they're the only producers of airplanes we assumed in this scenario, the world total is that we have 26 large airplanes and 22 small ones, right? Everybody with me? Okay, now the terms of trade we said is 1 large for 2 small. Will trade happen at this terms of trade? Okay, look at what we concluded in part C. Is this in the acceptable range for both countries?
Yes.
Yes, it is, right? So at this terms of trade, everybody will be happy. So trade will happen. That means after trade happens, okay, we said the US, okay, will produce 30 large because we'll specialize only in large airplanes. That means we'll produce 0 small because when we specialize in large, we don't have any resources left for small. And Brazil, in this case, will produce 0 large and specialize to make 30 small. So the world, okay, all of a sudden has 30 large airplanes and 30 small airplanes to consume. okay, we are better off because when we have more products, we're better off. Now, this is really cool because we're better off not because we got more resources or a new technology. We simply allocated our resources into what we're producing, right? We don't have a new awesome PPF that's higher than the last one. We're on the same old PPF. We just moved from one point to another. Okay, so this shows you that trade is beneficial. Now you might say, okay, fine, trade makes the world better, but who cares about the world, right? I want to know if I'm better off, right? So I don't care about making the world a better place. It's all about me. Okay, I'm the center of the universe anyway. I want to know if I'm better off. Okay, well then let's look at that. That's really what question E is asking you, right? Can we show that not only the world is better off, but individually each country actually gains as well? So let's go back to just our graphs from part A. I'll use it for part E as well. I'll just erase all this extra stuff. Okay. Okay, so like we said, okay, I don't know if that point actually might work. Before trade, we arbitrarily picked that the US was producing at 18 large and 16 small, right? So it's 18 large and 16 small. Call this point A. Okay, that was our production and consumption point, right? Because if you don't trade, we said this is before trade. If you don't trade with anybody, what you produce is what you consume. You don't have anything else coming in, right? So Brazil, okay, was producing at 8 and 6. Okay, so call this point X. This is Brazil's production and consumption point before trade, right? Everybody with me? Okay, now we said the terms of trade is 1 large for 2 small, which is acceptable to both. So trade will happen once they decide to trade, and hopefully they're smart. They'll go to their specialized point where the US will produce at point B, and Brazil will produce at point Y, where we specialize, right? Again, everybody with me so far? Okay, now we come together and trade. Now we can trade any quantity, the effects are the same, but for simplicity, let's pick a nice whole number. Let's say that the US trades 10 large airplanes with Brazil, okay? So at the terms of trade of 1 large for 2 small, that means we will get 20 small airplanes back when we sell 10 large to Brazil, right? So now let's look at where our consumption is, okay? We made 30 large at point B. We sold 10 to Brazil, so that means we have 20 large left for our own consumption, right? And for the 10 we sold, we got 20 small airplanes back. So our consumption now is at 20 large and 20 small, point C, right? Does everybody follow how I got to point C as our consumption, right? Well, you can see that point C lies above our PPF. What do we call a point that's above our PPF?
Unattainable.
Unattainable, right? This is a point that no matter how hard we try on our own, given our current resources and technology, we simply can never get there. We can never consume at C unless we have new resources or technology, which takes time to develop and discover, right? But if we trade right now, we can consume at C. So that means we are better off. We're consuming at a much higher level than we could reach on our own. In fact, the same effect will happen as soon as you trade. If you trade 1 large airplane to Brazil, okay, that means we'll have 29 left, and then we get 2, small airplanes back. So at 29 and 2, okay, I didn't draw this very, very well, but it should be, I guess 29 needs to be higher, right? So it should be a point slightly above our PPF right there, okay? So as soon as you start trading, that trade effect is going to kick in. In fact, if I connect B and C, Okay, like that. I know I missed it a little bit, but if I connect B and C, this red line is our new consumption possibilities frontier. When we don't trade, your PPF is your CPF, right? Your production possibilities are your consumption possibilities. But when you trade, your consumption moves higher above your PPF. So the US is clearly better off. We should be happy, right? What happened to Brazil? Well, let's look at it, right? Brazil produced 30 small airplanes, sold 20 to the US when we assume 10 large airplanes got traded, right? So they have 10 small left. They sold 20, they have 10 small left, but they also got 10 large back. So they are consuming at point Z, which is also above their PPF. Okay, in fact, if I connect Z and Y, this red line is their consumption possibilities frontier. So they are also better off. Now, remember, we started where with the US having absolute advantage in both products. The US is indeed superior in production in both large and small airplanes, but through trade, we still are better off, and so is Brazil. Okay, so because trade is based on comparative advantage, not absolute advantage. Okay, all right. Any questions or comments? I hope you think this is cool because, you know, you should be an econ nerd if you're in this class, right? Okay, all right. Okay, now that's the core of what I wanted you to understand in macro. Okay, we don't have a whole lot of time left because we did too much administrative stuff in the beginning, but I do want to review micro really quick as well, because you do have concepts from microeconomics that you do need. So if you click on the micro review questions I have, okay, let's talk about some of these things on there. So go back to that module and click on micro review questions, okay? And now I'm not gonna go through all those questions in great detail because we only have 13 minutes, but fortunately I don't think there's a whole lot of things I need to point out. So the key things here are utility, marginal utility, and diminishing marginal utility, right? So if you recall, utility is just a measure in economics for your satisfaction, how happy you are with your consumption, right? So when you consume things, it should bring you satisfaction. That's why you do it. Otherwise, if it brings you misery, then you should stop consuming whatever brings you misery. Otherwise, you're not rational. Okay. Now, utility is the concept economists came up with to measure your satisfaction. And it's a very abstract concept, and we use utils to measure it. And utils is this made-up measurement. And one thing we can say is, well, utils is numeric, and you can say, you know, when you know, Max eats a cheeseburger, Max gets 10 utils of utility. When Max eats a slice of pizza, he gets 20 utils of utility. That means Max does like pizza twice as much as hamburgers, okay? Now, if I say Chandler gets 30 utils out of each slice of pizza, that does not mean Chandler likes pizza 1.5 times as Max, because Max's 20 is not necessarily less than Chandler's 30, okay, because the utils are very subjective. So just remember that. Within one person, you can compare, okay? So Max actually gets negative utils from cheeseburger, I'm sorry. Okay. Yeah. Are you, I can't hear you. What'd you say, Max?
Sorry, I said you're fine. I haven't eaten meat since 6th grade, so if I had a cheeseburger, it would probably really, really mess with me.
Well, I'm glad you, I'm glad you realized that you would have negative utils and you're not eating cheeseburgers, so that means you're rational. I like that. Okay, all right. Now, marginal utility, okay, what is that? Utility is that general concept we just explained, but what is marginal utility? How would you explain that?
Oh, it's the satisfaction that you get from eating one more or consuming one more of a certain product.
Very good. So, like Coulter said, marginal utility is what you get out of your next unit of consumption, whatever it is, right? If it's a cheeseburger, is how much you enjoy the next cheeseburger. If it's, you know, a beautiful salad, then how much you would enjoy the next salad. Okay, so Well, marginal utility, okay, so first of all, I guess let's write this down. That is the change in your total utility divided by the change in your quantity consumed, okay? And there is a mathematical formula for it. And this marginal utility, we say for rational people, is diminishing, which means as you consume more and more something, you enjoy it less and less, right? So think about the last time you went to a buffet, right? I don't know when that was, because you know, if you were like me, the last time I went to a restaurant to eat was like March, so it's been a while. No, actually, I take that back. It was July. So I went to a restaurant and sat outside. So they had outside seating. But anyway, so the point is, well, the first plate you had, you were probably very glad you did this. Like, this is an awesome idea. I'm glad I'm doing this. And then versus the last plate you got, you're like, why the heck did I get this last plate? I can't eat this all, right? This is making me sick. Because the more you consume something, generally, the less satisfaction we get out of it. So that's why we call this the diminishing law of diminishing marginal utility, right? So now utility is important because it helps us decide how much we will consume, okay? And you know, the PPF tells us all about the production side of things, how much we can produce, but how much we actually produce, you have to add the demand side, how much people will buy into it, and figure out, you know, where our utilities maximized for consumers and where the profits are maximized for producers, right? That's what economics is really all about. So utility help us do that. And now the question is, well, how do you determine where, you know, the maximum or optimal consumption for a consumer is? Change the color. Okay, so optimal, oops, I can't write. Optimal consumption, right? Because the problem is we consume so many different things, right? How can I find the most, you know, satisfying combination of, you know, cheeses and apples and bicycles and computers and movies I watch and subscriptions to Netflix or whatever you consume, right? How do I find that perfect balance in the different quantities, okay? Well, that question is answered by looking at what's called marginal utility per dollar, right? Because when it comes to consumption, it's not all about the marginal utility you get out of something, but it's also about how expensive it is, right? I think, Ryan, when you took 151 from me, I was giving the example of, you know, I would love to have a you know, marginal utility from driving a Maserati, but the price tag stops me from consuming it. And you were like, yeah, it's not that great. It's like, oh man, do you have one? I can drive it. Can I borrow it? So,
no, I don't have a Maserati. I've heard that Maseratis are just a headache. I heard they break all the time.
oh, well, yeah. I mean,
I've never
I'm
driven
assuming
one.
if you can afford to buy one, you can afford to fix one. Right? So,
That's true.
yeah, but anyway, so the point is, okay, your utility, your marginal utility can be very high, but if the price is even higher, then you still won't consume something. So what we look at is something called marginal utility per dollar, which is your marginal utility of a product divided by its price, okay? Now, the optimal consumption is reached, okay, when the marginal utility per dollar of everything you consume equals each other. So if your marginal utility per dollar for apples, which is marginal utility of the next apple you eat divided by the price of the next apple you pay, if that equals your marginal utility of your, I don't know, bananas, and which equals your marginal utility of, you know, carrots, which all the way to marginal utility of the next zebra steak you consume. I don't know what is for Z, but the point is, if all of the things you consume have the same marginal utility per dollar, then you have maxed out your utility you can get out of your consumption, right? Because if they don't equal, you can always consume more of whatever is giving you more marginal utility per dollar, right? If your marginal utility per dollar for ice cream is greater than your marginal utility per dollar for gumballs, okay, then you should always consume more ice cream and you can become happier. But because of diminishing marginal utility, as you consume more ice cream, your marginal utility of ice cream is going to decrease. Then as you consume less gumballs, marginal utility gumballs will increase. And eventually, as this happens, then this will they will equal out, right? So when they don't equal each other, always buy more of whatever is giving you more utility. But once you reach the point where they all equal, then you have reached the what we call optimal consumption, or sometimes referred to as optimal consumption bundle. Okay, does that make sense? Why this is the ideal situation? Okay, so now, given this information, you can do some exercises, right? So, you know, if I tell you that, you know, Jason is at his optimal consumption, and so he just, you know, he gets marginal utility from, I don't know, let's just say hot chocolate. Marginal utility is 6 euros. The price of hot chocolate is $3. Okay. He also consumes, let's say, tacos. Okay, and tacos give him 12 euros. And what would be the price of tacos be, right? And if I already told you that he is at optimal consumption, well, then you should say, well, I know marginal utility of hot chocolate for Jason per dollar should equal marginal utility of tacos for Jason per dollar. And because he is consuming at his optimal consumption, so that means 6 over 3 equals 12 over price of tacos. So that tells me that tacos must be $6. Right, does that make sense? Okay, so this is kind of how you use it. And if I give you any of the 3 numbers in a 2-product scenario, you should be able to figure out what the 4th number is. Okay. All right. Now, okay, just now we mentioned that, you know, if you consume more ice cream, that means you're buying less gumball because, okay, of something called a budget constraint. A budget constraint looks almost identical to your PPF, okay, with one big difference, right? The PPF measures how much you can produce. The budget constraint, okay, by the way, is the budget constraint measured in dollars? Is your budget constraint your $500 per week of income? We don't know. Okay, you don't remember, I should say, right?
Sometimes.
Sorry?
Sometimes.
Sometimes? Doesn't have to be.
Can you repeat the question, please?
What is the budget constraint measured in? Is it measured in dollars?
It could be in dollars. It could be in time that you have to do an activity. It could be in different things. Whatever your constrained resource is.
Okay, so Troy thinks it's whatever your constraining resources are. Okay, but in fact, actually, budget constraint specifically is a constraint related to dollars, but not measured in dollars. You're thinking about scarcity, Troy. We all have scarce resources, yes, but budget constraint specifically talks about how many products you can afford to buy given your income. Okay, so it's measured in how many products you can buy given your income, but it's not measured by the dollar amount of your income, because your income doesn't really mean anything unless you measure it in what it can buy, right? I always tell my students, if somebody gives you 100 million Zimbabwe dollar, don't quit your job and think you can retire, right? Because the zeros don't matter, right? So let's say your income maybe is $200 a week. Okay, you consume 2 things. Okay, you consume pizza to sustain life, and you consume gas to get you to work and school and dates, and that's it, right? So the price of pizza is $10 each, and the price of gas is $2 a gallon, right? So that means your budget constraint, okay, is that at a maximum you can consume 20 pizzas. So if we do 5, 10, 15 and up to 20. And then the maximum amount of gasoline you can get is 100 gallons. Okay, so if you connect these two, this is your budget constraint. Okay, and so similar to a PPF, this tells you the combination of different goods you can afford to buy. You can buy up to 20 pizzas and no gas, or up to 100 gallons gas, no pizza, or somewhere in between where you buy 10 pizzas and 10 gallon, sorry, not 10 gallons, and see, 50 gallons of gas, right? Anything in between. And of course, if you buy something on the inside, that means you are not spending all your money. Anything on the outside, you cannot afford, right? Does that ring a bell now? So this is your budget constraint, okay? All right, well, we're officially out of time. We have one more thing I need to review with you called the indifference curve, but since we're out of time, I will just finish that up at the very beginning of next class. I guess I won't let you do your quiz for this just yet. I'll review the indifference curve with you quickly, and then have you do your individual quiz and group quiz in class next time, okay? Before we talk about chapter 2. Without the administrative stuff, hopefully we don't take nearly as much time. You know, we won't run out of time like this. Okay, so you don't have any homework for this week, but make sure you read chapter 2, submit your summary questions before next Tuesday, and then watch the video before next Thursday's class, okay? All right, enjoy your long weekend. I'll see you guys next week.
Thank you, Brother Ma. You have a good week.
Oh, thank you, you too.